Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together. This time, I would like to do an electronic work that acquires images with an IoT camera and saves them in Google Drive. This time, what we are doing is very simple. However, the method of using the Google Cloud API that we implemented is not limited to Google Drive. But you can use APIs of a great many Google services such as Google Map and Gmail. I think that the method of using Google API can be used with other software regardless of the programming language, so please refer to it. And you can do a lot with this basic content. For example, checking the contents of the refrigerator with a smartphone, sending an email when mail arrives, taking an image and sending an email when someone enters the room, etc. We would like to implement these practical application examples in the future. As for the operation image, the IoT camera acquires an image with the camera when it starts up. The acquired image is saved to Google Drive in the cloud on the internet using HTTP post. You can check the images saved in Google Drive by using the usual method of checking Google Drive, such as a web browser or application. This time, I logged into my Google account with Chrome and checked inside Google Drive. Here's where it actually works. Here is an IoT camera using ESP32 and OV2640. It is wired with jumper wires on the breadboard, and the program has been written and completed. The Arduino IDE serial monitor is displayed in the upper left, and the file status of Google Drive is displayed in Chrome in the lower right. Now let's get it working. Clicking the restart button restarts the ESP32 and captures images with the camera after booting. You can see that the log at startup is displayed sequentially on the serial monitor. Acquired images are uploaded to the Google Cloud on the internet via Wi-Fi via HTTP post. Once uploaded, the image file will be displayed in Google Drive. As you can see in the lower right, you can see that the Minions image captured by the IoT camera has been successfully uploaded and saved to Google Drive. This time, it will be the production of the IoT camera that has been operated. I would like to take a closer look at the microcomputer and camera used this time, including the reasons for their selection. If you want to know the specific method, I think that the content of this video is unnecessary, so please proceed to the next video that follows. As for the microcomputer to be used, I am using ESP32 this time. Why ESP32? Some people may think so. Let's take a look at selecting a microcomputer. As for microcomputers, I think you will have to start by choosing from a large category. It may not be desirable to compare the following three side by side, as they differ in price and performance. Also, there are various types other than these three, but I think that it is good to choose from this most major one first. This is because there are a lot of libraries on the internet for expanding functions and implementation methods for major ones, so it is easy to do various electronic work. Also, there are a great many types among these three categories, but I think that the details will be selected later, and first we will choose which of these three categories to use. As shown in this figure, if you want to do electronic work such as IoT devices, I recommend ESP32, which I am using this time as well. With Wi-Fi, you can easily implement electronic work using the internet, such as operating from a smartphone, and the ESP32 is highly recommended. In addition, ESP32 can be used with Arduino and has a rich library, making it easy to learn and develop. In terms of performance, the CPU and memory are highly functional, but the price is very cheap. It can be implemented not only for HTTP, but also for MQTT clients and web servers, so almost anything can be implemented. If I dare to mention the points that I am concerned about, when using Arduino, it requires a little more environment setting than hardware, and when implementing processing that requires a little CPU load such as AI functions, a slightly more advanced function such as Raspberry Pi, I think you will need something. However, if it is a normal electronic work, it is recommended to use ESP32 because most things can be implemented. This is the ESP32 body. There are many types of ESP32 as well. The official name of this product is ESP32 or M32E. The last E is the version, so there have been B, C, and D so far. But since it will be new in alphabetical order, it seems that the next one will be F. Also, ORM is the most standard model. But there are other models such as RAVer with large capacity memory. This RAVer image is B, so it is a slightly older version. It is good to buy the latest E. There are many other detailed types. But I think you should know these two types first. Regarding memory, ORM is 512KB. But RAVer has a large capacity of 8MB. Other than the memory capacity, I think that there is no problem in using it assuming that the specifications are basically the same. I think RAVer is better because it consumes memory when using the camera in earnest. Such as handling videos instead of still images. This time, we will use the standard ORM because we will only use still images without using videos. There are many other types of ESP32, but if you want to check them, please refer to the website of Espressif, the developer of ESP32. This ESP32 itself does not have a connection port with a personal computer. So we will use this ESP32 development board equipped with a micro USB port and jumper pins so that we can work on it. The ESP32 body is mounted in this part. The ESP32 development board mainly adds the following functions. 1. USB serial data conversion function for communication with a PC. 2. Voltage limit regulator function that converts USB 5V voltage to 3.3 volts for ESP32. 3. Jumper pins for wiring to the breadboard. There is also a switch that can be restarted. The specific circuit diagram is also shared on the official website. There are many types of ESP32 development boards available on online shopping sites such as Amazon. There are many products from Espressif, the ESP32 developer and manufacturer, to products made by other companies. Other companies' products tend to be cheaper, but if they meet the legal standards of each country, they may be cheaper. Next, regarding the camera, Omnivision's camera is widely used, so we will use it. The OV2640 used this time has 2 million pixels and is relatively inexpensive, so I am using it. UnitCam sells a camera module that comes with voltage regulators, resistors, jumper pins, etc. for easy electronic work, so we will use that. It is also used in M5 Stack's UnitCam, which has the same circuit and hardware configuration as here. The circuit diagram of UnitCam is also published on the M5 Stack website, so please refer to it if you are interested. There are many other products with high resolution such as OV3660. This time, I don't need such a fine number of pixels, so I'm using OV2640. Next, there are two main ways to save files to Google Drive as shown in this figure. There is a method using Google Apps Script, GAS, and a method using Google Cloud API, API. It depends on the purpose, but if you don't know which one is better, the API is more versatile than GAS, so it's better to choose the API introduced this time than GAS. I think it's good. This time it will be a method of using API, so I plan to post the method of using GAS separately. Let's take a look at how to use the API in detail. A lot of work is required to do electronic work, but roughly the following 3 tasks are required. Detailed methods for the following 3 methods are in 3 separate videos, so here we will only explain the outline. The first is to make settings related to Google Cloud. Ultimately we need to obtain a token for the IoT camera to access the Google Cloud, but the work required to do so is a little more complicated. I have uploaded a separate video with specific setting methods from setting up Google Cloud to how to acquire a token using the curl command. Second, it requires some electronic work on the hardware. Connect the microcomputer, camera, LED, etc. and work on the hardware. This time, I am wiring using a breadboard that allows you to freely change the wiring. Instead of suddenly creating a circuit diagram as a base, it is best to use a breadboard to create and study circuit diagrams on a trial basis while checking. The specific content is also uploaded in another video. The third is the program, which is software. How to operate IoT devices is determined by the program. This time it will connect to Wi-Fi on startup and get the image after connecting. After that, it has a very simple content of saving the acquired image to Google Drive. This time, I didn't do anything unnecessary and only this part in order to properly understand the content of using the Google Cloud API. The specific content is also uploaded in another video. This is just an overview, so that's all. As I mentioned earlier, there is a separate video for specific work, so please watch that content if necessary. We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.